Yeah, I'll. That's nice. Please, the number is to call her for class. Questions. Not hello, hi, what's up? Some of you, some of you who just enter people's DM. See what you just want. The guy one emoji puts the one that cover your face. Next thing is go and send catch for possible. So please, the number is not only the best patients on WhatsApp. Alright, so please stop it. Alright. With that said, I want us to start physics. Now, today's class will not be the one by the wayside because I tried to do math. I tried to see that everything I'm teaching you, or I'm trying to see that everything I'm teaching you today is more of the shortcuts. Yes. It's not how that's in physics, what you call in math, what you call mathematics today, and that is what you physics, what you call it is manipulation. Yes. Then you will not call it Mmanu. Yes. Alright, that's what you call it in physics. Alright, let's see. First of all, please let's the noise. Let's the noise. So that we can quickly revise our addition of vectors, then do multiplication, then we enter our assignment. And please, yesterday you were correct. Yesterday you were correct. Do you know why? There are certain things we are trying to make that work very simple. And in the process, we pulled it out, we'll still see it. So we have a short form to it. So AI man. Then you need an AI. Yes. So I believe what I will soon be calling it AI. Alright. So see, let's start with the addition of vectors. And today we are not going to be doing anything of us. There's a trying to pull it out. But this time not the short forms. He's talking about addition of vectors. Alright. Please look at this. This time around, we are no longer going to be considering 180. And the other ones will be considering here 90, here 180 should be 273, 60 going around. Now what we'll be considering is, we know that everything this side, not this side, is 90 degrees, should be? And this side is also 90 degrees. See now, but the second quadrant. The second quadrant. Addition of vectors. We are revising everything we've done during the week. We are using the Mmanu method. So this is first quadrant. If you like no correlation today, the plane, you know that this side is also like this side. It's not good. This is the fourth, and then thank you. Again on here. Third quadrant. Alright. Then this side. Is what? Alright, and you notice that every time I go is like 90 degrees. Please, what's the noise? Why is the class noisy? What's the noise? We know that in the first quadrant, is plus, is not true. And in the second quadrant, is plus, is not true. Why is minus? Do you remember? Yes. In the third quadrant, you know, here is minus, here is minus. Why here is plus and here is what? Minus. Alright. Now what it means is that if I ever see, please that's the noise. The first thing I'm teaching is to know the quadrants this way. We're no longer doing 90, 180 or whatever. So if I know this, if I happen to see an angle at any point, and that angle, let's say, is here, I will not use it. I'll make sure that whatever angle I'm using is the one that touches the horizontal. So this is the second thing I'm saying now. First is to know it by saying we are no longer doing 180 minus or 270. Everything is now under 1990. But we are paying attention to the signs of the programs. That's the first thing. Now, like I said, if I see an angle here, let's say I see angle here to the 30, should we notice that this angle started from the vertical and touching this? I will not use it. Anything on the vertical, I will not use it. What will I use? I will use the one that is touching the horizontal, the remaining. And notice, everything that we said is going to be 90. What we are just considering is 90, should we? Yeah. Now, 90 minus 30 is what? That is the angle we are going to be using. I see it. So the simple formula we are using today is simply, if I have this, I have this, I have this, I have this, I have this. If I have an angle here, I have an angle here, I have an angle here, I have an angle here. I'm not going to use any of these angles. I see it. The one I'm using is the one that makes contacts in the horizontal. This is the one I'm using. The one that makes contacts in the horizontal. So this is our working formula. I see it. Relax now. Relax. Are you taking notes of the formula? Yes. That is the first thing you need to do. Now, what it simply means, what this shortcut or this Mmanu method means is that we are no longer trying to assume that since it started from the origin there running around. No. We are not saying second quadrant has these signs, you will still put it. Now, if I see an angle here, let it be from the horizontal and use it. And this way, you will not see that everything you will be doing now will always fall under y to be sine and x to be cos. Are you seeing it? Yes. So, another thing, have you copied this number? Yes. So please, for a parasolic process, most of the things we are doing an introduction might not really be activating, but as you progress, you start to ask yourself, how I wish I copied it, or how I wish I was paying attention like it. So I said, which means that we're going to be using y to the sine theta, isn't it? And x what? Yes. Alright, let's try a perfect example of this. So I believe we're not going too fast. So which means that when I now want to do this, whenever I now want to do this, I will now say if I have my x and I have my y, I will pay attention to the signs now. Are you noticing it? We're not indicating it must come from the horizontal. If it's in the second quadrant, put all the signs in the second quadrant. If it's in the third quadrant, put all the signs in the third quadrant. If it's in the fourth quadrant, put all the signs. Then they indicate that if there's an angle given that does not touch from the horizontal, make it touch from the horizontal. Finish. Very simple. So we don't have to be stressed and running around to do that. So if I have this to be a question now, let's say they give me here to be 5. Let's say they give me here to be 4. This is a vector. Let's say they give me this now to be 5, and let's say they give me here to be 4. So using our x and y coordinates, we can find it, because we will now remember that first of all, this 4 that I have here, is it on the notice. Remember that the 4 itself is for x alone, is it not true? And x this side is what? This side is what? Here. Here. Which means that whatever is here now is going to be minus 4. Is it not true? So notice that the shortcut we are using is simply paying attention to what you are. Let everything you are be for you. Let everything you are be for you. That is what we are doing. So if I see, the only thing that we are not paying attention to is if I see an angle, that angle starts from the vertical, I will not use it. So I must discard any angle that starts from the vertical. I will use the one that starts from the horizontal. Very simple. So with that, we can solve this question. Alright, let's try to solve it. So which means when we finish now, at the end of the day, we know that whatever we do here, we always try to compare it with our parallelogram method. Do you remember? Okay. So when we finish, we compare with parallelogram method. If it gives us the same answer, that means we are very correct. And notice something about physics. Physics is something that anything you're doing, you must have to prove it. Physics is not like maths. Maths is not, you can prove, yeah? But it's not everything that requires you proving. What you require in mathematics is the formula. Are you aware? Yes. But every topic we will cut across in physics requires that even when you solve this, you must use this to prove it. Just like when you do your practical, they told you that T is equal to 2 pi root m over g. Shall if you use this t to solve, and at the end of the day, you do t equals to t over n, and it doesn't give you an answer that is close or the same thing, it means you are wrong. Are you saying it? Yes. So that is physics for you. You don't solve one thing and say that is the final answer. Alright, now let's go. So I will now say to do this vector, we know that anything that has to do with z axis, we always take it to the x and the y axis. So if I'm taking this 5 now to x axis, you see that it's going towards the angle. So with this pattern, the y will always be sine, the x will always be cos. This pattern is simply what is for you, let it be for you. So now I have 5 cos 60 degrees. Now if I'm taking it to the y-axis, remember that we are not using this angle, should you know? You said anything starting from the vertical, which is target. So it will now be away from the angle 5 sine 60 degrees. Okay, yes, okay, because it's on this quadrant, which means I should have really started with the signs. So that we don't make mistake. Second quadrant, what are the signs for second quadrant? Here is supposed to wait.
Yes,
X is negative, positive, so about 5 cos 60 and it's minus. Remember? Then look at this one, about 5 sin 60, yes. So what it means is that in this case, we must pay attention to what is for you, let it be for you. Everything for you. So x is for cos, y is for sine. Second quadrant is the second quadrant is for minus and plus. Here, let it be for you. Alright, now let's go to this one. This is 4, and this 4 is more than this. It's 4. And this side is on the x and it's minus. So for here, I will have minus 4. On the y, that 4 is not there. So it will be 0. Alright. So you now do the mathematics. So 5 plus 60 minus 4 is what? Minus 6.5. Can everybody be sure? Okay. I do 45 sine 60. 4.3301 like this. Alright. Okay. Now you see that we've been able to take this to the x and the y-axis. So at this point, we'll now do the resultant, which is r squared is equals to s squared plus y squared. And I believe I've proved to you, but I derived this. You are in class when we derive this formula. Why we don't use minus, that our general cosine is from cosine we get this 2xy cos. But notice that anything 90, once you have x and y axis, is now 90 degrees. Is it not true? I remember I told you 90, this one. Look here, no other finger. So 90 is 0, plus 90 is 0. So which means if I have plus 90 here, 0. And 0 times anything, this place will get out. So that is how I have this in Pythagoras once it's 90. So I have r squared is equals to 6, negative 6.5 squared plus 0.1 squared. So today we are going to do your own thing, Because I notice most of the time we try to simplify it, we end up putting ourselves in trouble. Well, do for me, 6.5 squared, what do you have? 42 points. 4.3. 18.7498, okay? Watch for me, r squared not the worst. I can claim this. So, if you do, first of all, I add it up. 60 points. Like this. 8. Okay. Now, that means taking the square root of both sides. What do you have? R is 7. Let's go to like this. Okay, which means that R is approximately 8. Is it not true? Remember that we started this, and we know that once it's a vector, they must give us unit. Either they give us Newton, they can give us meter per second, they can give us anything. So let me say this one is Newton. So that means that my final answer will be 8 Newton. Alright, and remember they did not ask us to find directions, you do? Assuming they ask us to find directions, since I've already got into x and y, what will I do? I'll simply say tan theta is equals to y over x, you mean? And y here is 8. Okay, yes. 4.3301. Is it not good? Now notice my x is negative, right? I will not put that negative sign. I will not, because in finding angle, my angle is not supposed to be negative. But yes, but when I finish finding this angle now, whenever they are asking me for direction, I will now go back and ask myself, in what quadrants do I have minus and plus? I will now subtract from that quadrant. So this is what I'm going to do. Let's do it. So I have 6.5. I have to for me tan theta equals to 6.5. 33 points. 670. Okay. 670. Alright. So that is tan theta. Okay, that means you've already done theta tan inverse of. Okay, so tan theta equals to tan inverse of okay, tan inverse of 0.666 like this. Okay, so theta is equals to which is set as 33.7 degrees. So this is not my answer. I'll now ask myself, in what quadrant do I have minus and plus? See, x here is minus, and y here is positive, minus positive. So it's in the second quadrant. So I will simply say, second quadrant is equals to 180, and I say 180 minus 33.7 degrees. So whatever I get here is my direction. I have got it what they have. 146.8 degrees. This is my direction. No. Look at where you're looking at. See, he's asking, since this value is less than 90, like we should go to first quadrant because it falls below 90, right? No, we will not do that. The reason being that what determines our quadrant is this. Where our x and y axis is. This thing automatically shows us that yes, we have everything on x and we have everything on y. Then which side of x or which side of y is on the second quadrant, and the second quadrant is 180. So that is how we do our direction. So you see that what we have already, see, since it's on this direction, this is north now. Is this not west? So if I'm to determine this, I remember that we always use this angle, is it not good? So this is more of west of north, not south of west. Because if it is north of west, remember the angle will be easy to do this is that of 30 degrees. So it's not hard. So I believe this pattern is simple. Is it not good? Yes. This pattern is not stressful. Now, let's use the same pattern. Assuming what I have here is minus, it means it's in the top quadrant. So whatever I get here, I will go to the top quadrant and say, what is the value of the top quadrant? 270 and 0. Yes. Considering the fact that this is the angle we use now. Yes.